All right, let's talk about a molecule that everybody's heard of, but maybe doesn't fully understand. Cholesterol. We eat it, our body makes it, and we need it. But here's the thing. Unlike sugar or fat, you can't just burn it off for energy. So how in the world does your body get rid of the extra? Let's dive right in and figure it out.
I love how our source material personifies cholesterol with this quote. It's like the molecule itself is telling us it has a major PR problem. It's absolutely essential. We need it for our cells, for our hormones. But yeah, get too much and you've got trouble. The real story, though, isn't about cholesterol being good or bad. It's all about how our body manages it.
And that really is the million-dollar question for today. Think about it. Too much sugar? Your body burns it or stores it. Too much fat? You can use it for fuel. But cholesterol? Its chemical structure is tough, it's stable. The body can't just snap it in half and turn it into carbon dioxide and water. So it needs a totally different plan, a special disposal system for this unique molecule. So, to really get this, we have to appreciate the problem itself. The body's standard toolkit for breaking things down for energy, it just doesn't work on cholesterol's core structure. It's like trying to open a can with a fork. You need a different tool. Okay, check out the key word on this slide, conversion. This is so important. The body isn't destroying cholesterol. It's remodeling it. It can't shatter that core steroid nucleus, so it has to chemically disguise it as something else, something it can get rid of. This is way more sophisticated than just simple breakdown. It's a full-on biochemical makeover. So if conversion is the name of the game, where does all this magic happen? Well, the hero of our story is definitely the liver. It's the body's master chemist, and it's come up with this brilliant solution, turning that unwanted cholesterol into something incredibly useful, bile acids. Let's see how it pulls this off. The whole thing kicks off with a critical first reaction called hydroxylation. You can think of it like the liver adding a little chemical handle to the slippery cholesterol molecule, making it easier to work with. This first step creates a new molecule, 7-alpha-hydroxycholesterol, and that one reaction sets off a whole chain of events that will eventually reshape cholesterol into what we're after, primary bile acids. Now, what's really cool is that this entire complex pathway is basically controlled by one single checkpoint. One enzyme, cholesterol 7-alpha-hydroxylase, is the gatekeeper. It's the master switch. How fast this enzyme works determines how fast the whole cholesterol cleanup happens. If it's running slow, the whole assembly line slows down. It really is the boss of this whole operation. And after all that fancy chemistry in the liver, these are the main products. The cholesterol has been officially transformed into two molecules, cholic acid and shenodiacholic acid. These are what we call our primary bile acids, the first major output from the liver's conversion factory. But wait, the liver's not quite done. These bile acids are pretty good, but they can be made even better. Our bodies are all about efficiency, right? So the liver performs one last modification to create a supercharged, more effective version called bile salts. This next step is called conjugation, which is just a fancy way of saying the liver attaches an amino acid, either glycine or taurine, to the bile acids we just made. You can see it right here. Cholic acid gets a glycine and becomes glycocholate. It's a perfect example of the body mixing and matching different building blocks to create a brand new tool for a specific job. So you might be asking, why bother with this extra step? Well, because this final tweak makes these molecules way better at their day job. Turning them into salts makes them much more soluble in water. And since your intestines are a watery place, this makes them amazing emulsifiers. They're experts at breaking down the big blobs of fat from your food into tiny little droplets that your digestive enzymes can actually attack. Okay, now the body has spent all this time and energy making these super useful bile salts. It would be an incredible waste to use them just once and then let them go. So what does it do? It develops one of the most efficient recycling programs in all of biology, the enterohepatic circulation. And this chart really tells the whole story. It's staggering. After the bile salts help digest fats in the intestine, about 95% of them are reabsorbed back into the bloodstream, sent right back to the liver, and put back to work. They just go round and round. It's a beautiful example of metabolic efficiency. And right here, this is where it all comes together. That tiny 5% that isn't recycled, the small amount that's lost in our waste, that is the final exit for the cholesterol that started this whole journey. This small daily loss is the main way our body actually gets rid of excess cholesterol. It's the bottom line. But there's one last twist in the tale. Our gut bacteria get in on the action too.
The trillions of microbes living in our intestines actually perform their own chemical edits on that small fraction of bile acids that are on their way out. They tweak them a bit, turning them from primary into secondary bile acids. It's one final transformation before they leave the body for good. So this is a beautifully balanced, intricate system. But, like any complex machine, sometimes things can go wrong. When the balance between cholesterol and the bile salts that keep it dissolved gets thrown off, you can run into some serious health problems. One of the most common issues is gallstones. In healthy bile, you've got plenty of bile salts to keep the cholesterol dissolved, kind of like sugar dissolving in coffee. But if your bile salt levels drop or your cholesterol levels just go through the roof, there's not enough solvent to keep it all dissolved. The cholesterol starts to crash out of solution and form hard crystals, or stones. And if one of those stones causes a blockage, the whole system backs up, like a traffic jam. Bile can't flow out properly, so bile acids start to build up in the blood. This can lead to some really unpleasant consequences, like jaundice, intense itching, and trouble absorbing dietary fats. But here's the fascinating part. Understanding this problem also shows us a way to fix it. We can actually use this pathway to our advantage. So let's look at a type of drug called a bile acid sequestrant. The way they work is actually pretty clever and simple. The drug goes into your intestine and basically latches onto the bile acids, preventing them from being recycled. It blocks that 95% loop. The body senses this and says, whoa, I'm losing on my bile acids. I need to make more. And to do that, the liver has to pull more cholesterol out of the blood, which, in the end, lowers your overall plasma cholesterol levels. Okay, so let's wrap this up with the absolute key takeaways. Number 1, you can't destroy cholesterol. You can only convert it, mostly into bile acids in the liver. 2, one single enzyme, cholesterol 7-alpha hydroxylase, is the master controller of this whole process. 3, the body is a master recycler, reusing 95% of its bile salts, making that lost 5% the main exit route for cholesterol. And finally, if that delicate balance is upset, you can end up with things like gallstones. And that's where we'll leave it. The body takes a molecule that could be a problem, one it can't even break down for energy, and it brilliantly transforms it into an essential tool for digesting our food. It's not just waste management, it's biochemical upcycling at its finest. It really just shows you how elegant and resourceful our metabolism can be. Thanks for watching.